we're going to practice with the concept of a subgroup and walk through the intuition behind this statement that if G is a group and if H and K are subgroups of G, then the intersection between H and K is also a subgroup of G. So I'm going to talk through the intuition and prove it simultaneously so you really master these ideas with subgroups. It's a standard first exercise or first theorem in group theory. So the way I like to look at it is, what does it mean for something to be a subgroup? It means it's closed under multiplication and inverses. Okay, so one way of looking at it is for H intersection K, what we want to show is that one, the identity is in H intersection K. Okay, so this is important. So H intersection K is non-empty. And condition 2 is that if x, y are in H intersection K, then we can conclude that x, y inverse is also in H intersection K. So this is a convenient subgroup criterion. Sometimes people show that the product of two elements of the subgroup is also in the subgroup, and the inverse of an element in the subgroup is also in the subgroup, and then conclude that the conditions are satisfied. But we can do it all in one go. Now I'm going to show you a beautiful picture. What we do is we draw this nice Venn diagram. So I'm going to have H and K. Okay, these are both subgroups of G, and we want to look at H intersection K. Okay, which is this intersection in the Venn diagram. Now, what's cool here is that if we think about what the condition we want means, well, first of all, we know the identity is in the intersection because it's in both H and K. Both H and K are subgroups, okay? So that's number one. And number two is that if we have x and y inside the intersection, we want to show x, y inverses in the intersection. But we know that x, y inverse, because x and y is in the intersection, x and y is in H, and therefore x, y inverse is in H, right? So we know that whatever x, y inverse is, it's somewhere inside the H part of the Venn diagram. But by the same reasoning, because x, y is in K, we also know that x, y inverse is in the K part of the diagram. That means that it has to be in the overlap, which is inside here. So that means that x, y inverse is in H intersection K. Now I want to go through the process of writing rigorous math proofs. This is the intuition that I like to visualize it. Sometimes the logical symbols can obscure the intuition. So that's the intuition. What is the logic? What are the actual symbols behind this? Well, the symbols are, first of all, we can say that firstly, so I write the proof this way. Firstly, since E is in H and E is in K, because H and K are subgroups, we know that E is in H intersection K. Okay, we know E is in H intersection K. And similarly, you can also say that if x, y is in H intersection K, then we know that because H and K are subgroups, we know that x, y inverse is in H. I could put a bracket since H is a subgroup. So we're carefully sort of going through what the conditions are. Okay, what are the conditions we're using? Of course, it really matters that we have to use that both H and K are subgroups. The statement is not true otherwise. So in math proofs, it's always helpful to think about what you're using and make sure you really are using that, unless the statement is generally true. In that case, that's also instructive. But in this case, it's fundamental. So xy inverse is in H since H is a subgroup, and xy inverse is in K since K is a subgroup. Okay, so I'd write that since K is a subgroup, and therefore we conclude that xy is in H intersection K. Okay, xy inverse is in H intersection K. Okay, so I could sort of append this to the end of the proof. Therefore, we have that statement. Okay, so that's just an abbreviated way of writing it, but we just sort of go through the hypotheses that we are using. So that's a practice with this, and as a generalization, you can also show the intersection of arbitrarily many subgroups of a group is also a subgroup. So that's an exercise I encourage you to try to do. Why is the intersection of a finite number of subgroups also a subgroup? You know, how would you go about proving that? Drop a comment down below for practice. And also, how would you prove that the intersection of an arbitrary family of subgroups of G is also a subgroup of G? For example, infinitely many subgroups. Is it the same reasoning? You could do it with different reasonings or with the same reasonings. I read every single comment and do my best to respond to them. So definitely drop a comment down below. Let me know what you think. And check out my channel for lots more cool videos on group theory. I'm a professional mathematician, and my research area, one of my research areas, is group theory. So what better place to learn group theory from? You can check out my playlist here on group theory videos, and this video here that you're gonna love, that is on a fun math topic that could be group theory. So check it out, and I'm super excited to see you in the next video.